All right, this is our fraction multiplication problem, and it's equal groups total unknown fraction multiplication problems that we're going to be working on. Now, in many of these videos, I have been using examples with, baking and flours, and I am repeating this context not because I think it is especially important, but because I'm trying to give sort of a basic structure to work from. And then once you really understand this basic structure, well, then hopefully you can expand that structure to cover any sort of context you want to make your problems much more interesting to you and your students. So, again, this says if a batch of cookies requires blank cups of flour, then how much total flour will I need if I am making blank batches of cookies? So I've got the number of batches times the cups of flour per batch, and that equals the total cups of flour I will need. So this is just our basic equal groups total amount unknown word problem structure. And as we draw these, there's a lot of ways you can draw them, but I'm going to be working towards more structured drawings. So for this first one, let's just say, I want to make 2 batches of cookies. Each batch takes 3 cups of flour, so I'm going to need 2 times 3 equals what? Or we know that 2 times 3 will equal 6 total cups of flour. Now, one way to draw it is to say, well, there's 1, 2, 3 cups of flour for one batch, and here's 1, 2, 3 cups of flour for a second batch, and there is nothing wrong with that. However, I am going to start to draw some of these problems slightly differently so that I can start to work towards more of area or array models. If you remember area and array models, they had numbers going this way and numbers going this way. And so what I could do is I could do 3 cups of flour for one batch, and then another 3 cups of flour for the second batch. And when I do that, you're going to see the number of batches going this way and the number of cups going this way. But you can still see there's 6 total cups that are going to be needed. All right, the second problem says we need to make 2.5 batches with 3 cups. So we will need 2 1/2 batches with 3 cups per batch. How many total cups of flour is that? And so that is the problem that this one is going to ask us to do. And if I were to solve it algebraically, that would be 5/2 times 3 over 1 would equal 15 over 2, which is 7 1/2. Now, I could say here is 1, 2, 3 cups, one batch, 1, 2, 3 cups, 2 batches, and we only want 1/2 of a batch. So rather than the full thing, I would only take half of it for this half batch. So for 2.5 batches, we could hopefully see we would need 1, 2, 3, 4, 5, 6, 7.5 cups for our 2.5 batches. Now, let's try this same drawing, but let's go, instead of all in a row one direction, let's try going where the cups is one direction and the batches is another. So if I go 1, 2, 3 cups for one batch, I'm going to move that up a little bit. If we have 1, 2, 3 cups for one batch, and then 1, 2, 3 cups for another batch, and then we just need 1/2 of a batch. So if I do 1, 2, 3 cups, I don't actually want the whole thing, I just want the half. And so now again we could see what's the total amount we need. 1, 2, 3 full cups, 4, 5, 6 cups, and then we would need 1/2, 1/2, and 1/2. And so if we count those up, all right, this half and this half should make another cup, so that would be 7 cups. And again, we would have 7.5 cups. And so we can start drawing this way, and it provides different benefits because it's easy to chop something in half vertically like this, where it might have been harder to chop it here because you would have to know exactly where to chop it. All right, what's the next question? 2.5 batches, but we need 3 1/3 cups per batch. So we have 2.5 batches, and it is 3 1/3 cups per batch. So algebraically, that would be 5 halves times 10 thirds. So that would be 50 over 6. And that would be then 8 times 6 is 48. So 8 and 2/6. So that would equal 8 and 1/3. Okay, but let's go ahead and see if we can draw this thing. I need 3 and 1/3 cups per batch. So there's 1, 2, 3, and 1/3. So that would be one batch. And then I need another 1, 2, 3, and 1/3 cups for the second batch. And then if I were to draw another 1, 2, 3, and 1/3, that would be a whole third batch, but we don't want a whole third batch. We only want half of that, and so I can slice it this way. And now we can see how much we have, which is we would need all of this, all of this, all of this little bit, all of these things. And we have an accurate picture, and all we have to do now is count how much we have. But when we count things at the moment, we're going to have a whole bunch of different fraction sizes. For example, this thing is going to be a third, this is a half, this is a sixth. And so when I count those, I'm going to be adding up different fractions of different sizes. Or I could make them all the same size, which would require chopping these ones down the middle, and these ones in thirds this way. And now we can see we have 1, 2, 3, 4, 5, 6 holes, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sixths. So that'd be 6 holes and 14 sixths. But 14 sixths is the same thing as 2 and 2/6. So really we get 8 and 2/6, or 8 and 1/3. But the nice thing with these pictures is they also start to model all the different things that are going on up here algebraically. So I just chopped the small fractions into sixths. However, I could have very easily sliced all of these things into sixths. We will focus a little bit more on this in a moment. Now, every single one of these yellow things is a sixth of a cup. And the question is, how many of them are there? Well, if I count this way, there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I count this way, there should be 1, 2, 3, 4, 5. So 5 times 10 would be 50 sixths. And then, again, we could rearrange that to come up with our final answer of 8 1/3. All right, what was the last one? 1 1/4 batches, 2 2/3 cups per batch. So 1 1/4 batches times 2 2/3 cups per batch. So let's draw this same picture again. If I have 2 cups and then 2/3 of a cup. So again, that would give me one batch. And now if I were to draw another batch, that should be 2 2/3 cups. But again, I do not want this whole thing over here. I only want 1/4 of a batch, so I just want 1/4 of this. So I'm going to chop this thing into 4 equal pieces. And then we can say, well, how much stuff is here? We have the 1 full batch, and then we have the 1/4 of a batch, which is just use 1/4 of that flour. So how much total flour is that? And now, again, we could count, and we have all these different size fractions, which we can say there's 1 cup, 2 cups. And now these fractions are all sorts of different sizes. That's 1/3 and 1/3 and 1/4 and 1/4. And these are, what, 1/12 and 1/12. And so we could put all those together, or we could turn these things into same size fractions, which would happen if I were to chop these things all into fourths this way. And if I were to chop these things into thirds this way, Now, everything should be the same size. Each one of these little yellow squares should be a 1/12 of a cup of flour. And if I count up, there's 1, 2, 3, 4, 5, 6, 7, 8 that way, and 1, 2, 3, 4, 5 this way. So 8 times 5, so there should be 40 yellow squares, each of which is a 1/12 of a cup. So that is 40 twelfths cups, or 3 times 12 is 36, so that'd be 3 and 4 twelfths, which is equal to 3 and 1/3 cups flour is how much we would need total. Now, if we were to do this algebraically, this should be 5/4 times 8/3, multiply top and bottom, and we get 40 twelfths, and we are right back to where that picture took us. Now, the one thing I was saying is these are working closer towards area models. For example, if I were to just look at this picture, right, and say something is 2 and 2/3 times 1 1/4, if I were to think of an area model, well, that could really say this is, 1 and 1/4 this way, and 2 and 2/3 this way, and we are really interested in this overall area. And when you look at an area model this way, sorry, that 2/3 is messy. What you get here is basically the same picture that we had before, which is this area in the middle is 2 times 1, which would be these two holes. This section over here would represent 1/4 times 2, and that would be this part right here. Right? We have 1/4 of the 2 cups. This section up here would be 2/3 times 1, and that would be right here where you have 2/3 of 1 cup. And then the final section in the area model would be 1/4 times 2/3, which is exactly what we have right here. It is 1/4 of the 2/3. So, again, when we draw fraction pictures, I'm not going to make you draw area models, but once we start organizing things like this, you can start seeing how they are not far off from the area models we were doing before. All right, moving on down. Let's come up with a more refined equal groups definition. So before, we did number of groups times things per group equals total things. For example, if there's 4 apples in a bag, and how many apples will I have if I buy 3 bags? That is 3 bags times 4 apples per bag equals 12 totals apples. Now, because we're dealing with fractions, and the groups may not be whole groups, the things in the group may not be whole numbers, so a more refined definition could say the number of groups or fractions of a group, because maybe we want to make a half of a batch instead of a full batch, and then this is the amount of things in one whole group, because sometimes we don't even have a whole group, we want one less than a group, and then this is the total amount of things in our groups or fractions of a group, because sometimes this number is even less than this number. If we don't even want a whole group, we want a fraction of a group. So here is an example. So it says a batch of cookies requires 1 1/4 cups of flour. Then how much flour will I need if I want to make 2/3 of a batch? So I am not even doing one full batch. I am doing less than a full batch. 2/3 of a batch times 1 1/4 cups per whole batch will equal this. And this is the total amount of flour in 2/3 of a batch. So this number is actually going to be less than 1 1/4, because 1 1/4 was the amount in one whole batch, and we have less than a whole batch. So it's just slightly changing the equal groups definition to allow for fractions as the group size or fractions as the number of groups. Now again, one more time, we could solve this thing with a picture, just like before. So 1 1/4. Hopefully that looks like 1 1/4 cups of flour, but that's what we would need for one full batch. So this way, we're going up 1 1/4. This way would be 1 batch. But we don't want a full batch. We only want 2/3 of a batch. So let's slice this thing. And now 2/3 would represent this quantity right here. And if we want to know what that is, we simply need to count it up. This thing is chopped into fourths going this way, so I will chop this into fourths. So we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things, each of which is a 1/12 of a cup. So we should have 10/12 or 5/6 cups of flour is what we would need. Now again, algebraically, this would say 2/3 times 5/4 equals 10/12, which is exactly what we just did. All right, that is it for this video.